morning, time for geometry. Right, people, let's have a look. I thought that I might give you some rules before I start with your geometry. Because when you do circle geometry and the problems become a little bit complicated, I always say to my learners, take a color pen or a pencil and mark everything you see in a color. Because if you mark something, it's something that you saw because of all the theorems that you know, but you cannot just use it in your proof. You'll have to give a reason why you said that angle is equal to another angle. So let me just show you. I just quickly wrote this morning in rough because I thought it might help a little bit. Let's have a look. If you look at your sketch, don't look at the questions. Look at your sketch, look at the information. Highlight the information so that you know exactly what you can use and what you have. The first thing you look for is a midpoint. If there's a midpoint, you check for the following. Radii, which will give you an isosceles triangle. A line from the center, perpendicular on the chord, that will bisect the chord. An angle in a semicircle is 90 degrees. And an angle at the center of the circle is twice the angle on the arc. Now that one, I use my fingers. I love fingers in geometry. There's your midpoint. Go down. That angle there will be twice the angle on the arc coming from the same chord. And the chord starts on the arc and ends on the arc. You mustn't forget that. You can't have a line there and say this is an angle at the midpoint. You understand what I'm saying? From this graph, you can get this. Angles on the same chord will be exactly the same. So when you have a midpoint, there's quite a lot of things that you must take into account. If you have two chords that's equal in length, the angles on the arc on each of these chords will be exactly the same. So people, actually there is 6 things that you must check for when you have a midpoint. Now when I do a sum, every single sum I do, I check for a midpoint, and then I check whether I have some of these in my sketch or not. If there's no midpoint, you don't need any of these, but only that one can be in a sketch where there's no midpoint. Can you see that? Okay, then you check for a cyclic quad. Now when you have a cyclic quad, you check for 3 things. Number 1, the opposite angles adds up to 180. The exterior angle is equal to the opposite interior angle. If you have diagonals in your cyclic quad, people, then you must check whether there's diagonals in your cyclic quad. See? And if there's diagonals, you can go back to that theorem. On each of these chords, you will have a pair of angles which will be equal. That one, that one. On this chord, that one and that one. On that chord, that one and that one. And on this little chord, that one and that one. Please, please, don't forget to check for this type of angles. The others are actually easy to check, but this is not always easy. And there must be diagonals in your cyclic quad before you will have angles like this. If I leave out this line, then it's actually that one, where you have the 2 angles on the same chord. People, they don't have to tell you that they are giving you a cyclic quad. If you have 4 angles on a circle, it is a cyclic quad. And you also have to prove a cyclic quad. You use one of these. We will do 1 or 2 of those so that I can show you how to prove. The proofs are actually your more difficult problems. Now, I don't think in the June exam they will give you a lot of proofs because you've just done all the geometry now. But with grade 12, you can expect anything. Anything is possible. It depends on who sets the paper. Right, then you check for a tangent. Now, when you check for a tangent, there's also 3 things. The first thing, the radii is perpendicular on the tangent. Radius perpendicular on tangent. Number 2, If you have two tangents starting at a point outside, going to the circle, those two tangents will be equal in length. And then the very important one, the angle between the tangent and the chord. There it is, right at the bottom. Aha! Remember, the angle between the tangent, I actually want to write it there for you. Tangent, and there's your chord, because they meet in the same point. Can you see that? Now, people, the angle that is formed between this tangent and this chord will always be equal to the angle in the opposite segment. And that angle must be on the arc of the circle. On this side, you also have an angle. If I lengthen my tangent there, there's also an angle there between this tangent and that chord. So, this angle will be equal to the angle in the opposite segment. People, and then you are really supposed to look for everything that you've learned from since grade 7. Angles on a straight line, 180 degrees. Vertical opposite angles, equal. Parallel lines, you look for alternate angles, you look for corresponding angles, co-interior angles. Okay, then angles of a triangle adds up to 180. Isosceles triangles, two base angles are the same. And then people, there's another one that's very, very, very important, and that is the exterior angle of a triangle. People, I haven't seen a grade 12 paper that doesn't have at least this one once in the geometry questions. So you must really make sure that you know all your old work, plus this is your circle geometry. In grade 12, you did proportional geometry and you did similarity. But for grade 11 work, these 9 theorems, and of these theorems, you are supposed to know number 1, number 2, number 5, and number 9. The proofs of those theorems. And people, if you know them, it's a 5 or a 6 marks that you have, because you know your theorems. They normally ask 2 theorems at the end of grade 12. And you will get 2 in June also, and 2 in September. So please make sure you know these theorems, plus your grade 12 theorems. I'm not going to do theorems because this is supposed to be theory that you know by now. You are actually the bright learners, aren't you? Okay, people, let's do sum number 1. I wrote there again, and I'm going to say it over and over again. Use highlighters or color pens when you do geometry. You cannot do geometry without that. Okay, right, so let's have a look at our first sketch. Oh, it looks quite difficult, but it's not so difficult, people. In the diagram, the circle center O. Stop. You've got a center O. There it is. Go there. Check. Check for four things. Are there any radii? Yes, there are. Take your color pen. We can't do this on color here, but we mark that in another color. So you'll have to give a reason when you use that. Okay? Then the center. Are there an angle at the midpoint? Oh, beautiful. Look at that. From the midpoint to chord BC. From chord BC up to D. So this angle is going to be twice this angle. And if you see that, it's 110 there, so this one is 55, but we will do it in the sum. Right. Are there a diameter with an angle of 90 degrees on it? No. Are there any line from the center perpendicular on a chord? No. You see what I did? I checked everything. Okay? Are there any angles on the same chord that might be the same? Look at this. BC. A, D. So those two angles will also be the same. You could have done it with your angle at the midpoint also. O, A. O is twice A. O is twice D. They are angles subtended by the same chord. The marking is more important than anything else before you even start looking at the questions. Because the moment you look at the questions, you are confused because you don't know where to start. But if you've marked little things there, you'll know exactly what to do. I'll show you now when we get to the sketch. Then they said AB parallel to DC. AB parallel to DC. Do I have any alternate angles? Aha! D is equal to B. Please remember, people, when you do alternate angles, it's a little Z that you draw. This short line and this short line of the Z must be on the parallel line. Otherwise, those alternate angles will not be equal. If you do corresponding angles, it's an F. Now, corresponding means on the same side. So, at the bottom of the short, and there's your parallel lines. There they are. At the bottom of the parallel lines, on the same side of the longer line of the F, those two will be corresponding and they will be equal. The two on the bottom, at the bottom, if your F might go on, those two will also be equal to one another, but they will differ from those two. Okay? So please, these are the actual two that they ask in your grade 12 sums. You don't often see co-interior angles. Actually, in the 4 papers that I did, I couldn't see co-interior angles. But those two, they are all over. Let's see whether we have another alternate angle here. A, the whole of A will be equal to this one. Look at the Z. There it is. Can you see it? From there, there, and this one is from there, there. So it's this angle and that angle. That also is alternate angles because of the parallel lines. Are there any corresponding angles? No, people, because you cannot draw in an F anywhere there on your, maybe you can. Yeah, this, look at this. But you're not necessarily going to use this one. But just, please, if they give you parallel lines, so this whole angle will be equal to this whole angle. If you give you parallel lines, make sure you use it. Because they won't give you something in geometry that you are not going to use. Right, people? And then they said the chords intersects at E, and all those lines are joined. So now we've looked at everything given. Next thing that you must check after the midpoint, cyclic quad. Are there a cyclic quad? No. There are no cyclic quad. If there was a line there, this would have been a cyclic quad. That is why I can also say this angle is going to be equal to this one. Look at that. 1, 2, 3, 4 angles equal to one another. Why? Why did I say those two are equal? From A and D, you go to B. From A and D, you go to C. Angles subtended by the same chord will be same. You see, now I've marked, I hope, everything that I could. Isosceles, then these two will be equal. I'm just doing it lightly because if you mark too many things, it becomes quite difficult to do the sum, but at least you can see that those angles are equal. Okay, let's have a look. The first question, calculate the size of the following angles giving a reason. And the first one is D. D. There's D. Now, people, if we didn't mark it, we would have had looked for this, and maybe some of you won't even see it. But we've marked it. We said that one is twice that one. And you people, the moment you start with your sum, you must start with the given angles. Because from there, you can determine another angle, from there, another angle. I always said to my grade 8s, years ago, Geometry is like climbing over a river, a shallow river with rocks. You jump from this rock, you go to that rock, you go to that rock, you go to that rock, because, now my hands are not on there. From this rock, you go to the next rock, to the next rock, to the next rock, before you reach the other side of the river. So you won't always be able to immediately get the angle that they ask. Sometimes you must say this one is equal to that, but that one is equal to that, so that one will be equal to this one. You understand what I'm saying? Don't try to do it in one step always. This one was very easy. I guess it was only, it was 2 marks. Because people, if you don't give reasons, you don't get marks. If they say to you, you don't have to give reasons, then you can leave the reasons. But normally in geometry, your reasons are more important than the answer. They will subtract the mark here if you didn't give your reason. Angle at center is twice the angle at the arc. You can only give that reason, it will be fine. Next one, 8.1.2. 8.1.2. They said determine A. Now, I said A is equal to D, which is quite correct. Look at that. On the same chord. Angles, or you can say angles in the same segment. On the same chord or angles in the same segment. You can't take that chord and then say this angle will be equal to the angle that side. They must both be in the same segment. What's a segment? This is a segment and that's your smaller segment. So the 2 angles must be in the same segment. So that was also very easy. Then they said E2. Now there's E2. Can you see E2 there? There it is. Right, now how on earth am I going to get to E2? I didn't mark it, but let's have a look. Now let's go to E2. This is the one where you have to climb from one rock to the other rock, to the other rock. You won't get there immediately. Okay, let's have a look. B is equal to D. B1 is equal to D. Why? Alternate angles. We have already marked it. Wonderful, people. Then, B1 is 55. It's already been proven. Okay? That is D that we've proved. So, then we go on. But A is also 55. We said B1 now is 55. That one is 55. Ah! Can you see what I said just now? Look at this. E2 is the exterior angle of this little triangle. In other words, E2 is A plus D. Can you see that? Wow, people, you must be very alert when you do geometry. But the geometry normally comes at the end of the paper, which is good, but by that time you are quite not feeling well at that moment. Because why? You went through all the other topics, you struggled with some of the sums. When you get to geometry, you can be quite tired. But people, drink is what can I say? What must you drink? Vitamin B. Anything to make you bright for that morning. Keep up your brightness until the end of the 3 hours. Okay. When you get to geometry, then you take your time with the geometry. If you struggle with a question, you leave it. You come back later. But the problem is when you come back later to geometry, it's normally a sum that you have to do right from the start to see why I couldn't do the last problem. So try your best, and if you can't do maybe the last question or the second last question, you leave it, and later on you can come back. But try it at least 2 or 3 times before you leave it. Geometry only. Geometry only. Because one thing follows the other in your geometry. And don't do geometry first, because geometry eats your time. It eats your time. And if you do it first, you won't have time for the other work. Geometry is more or less 40 marks. Your trigonometry might be a little bit more marks. And then your analytical also more or less 40 marks. So it's 3 huge topics. Start with your analytical and your data, which is easy, and then go to your trigonometry and your geometry. Okay, but I think that is the order in your paper also. Don't try to change the order. Okay, and if you leave a sum, you leave a space. You don't say, oh, I had a chap who always made the arrows, huge arrows. Miss, look at the back of this page. Miss, look at the back of the exam paper. I went on there. No, you don't do things like that. You know, people, if you mark, I've been marking for many, many, many years. You feel so frustrated if you get a paper like that. Because then it takes double the time to mark it. You must go back and look for a question, come back again, go back, look for a question. You just leave spaces where you couldn't do a question and go back there. Okay, right people, let's go on. So now we know that E2 is 110. E2 is the exterior angle of that little blue triangle. Can you all see that? I promised you that there will be an exterior angle in a lot of these sums. Okay. Then they said, the last one, prove that BEOC is a cyclic quad. Now you take another color and you draw it in there, but my colors are all black here. BEOC. It's always good to highlight or color in that quadrilateral, which you must prove. Now people, if you must prove a quadrilateral, you cannot say this angle is equal to that one. It's a quadrilateral. Because it's not yet a quadrilateral. Your proof must end with, therefore, EBCO is a quadrilateral. So, you can use any other knowledge except the knowledge that you have on quadrilaterals. Now, let's have a look at this. Are there any exterior angles for this quadrilateral there? It's not a cyclic quadrilateral yet. No, you get an exterior angle when you lengthen one of the sides, and no one, I just lengthened that one, but it's not necessary. So, you're not going to use that. Will you be able to prove that these angles opposite each other is 180? Woo, I don't think so. We don't have E3, we don't have that, so we won't be able to do that. We will be able to find B3 and C1. Why? Because this is C1 and 2. These two will be equal because of the, no, not up to there, because of the isosceles. Can you see that? Just keep that in mind. No, I won't be able to work with opposite angles. I won't be able to work with exterior angle. So the only thing that's left, are there diagonals? Yes, there are. So I should have 4 pairs of equal angles if it is a cyclic quad. But look at this. We have just proven E2 110. Can you see? E2 and D1 are subtended by the same chord. And if two angles subtended by the same chord is equal, that quadrilateral will be a cyclic quadrilateral. So you will be able to draw a circle around this quadrilateral. People, and you don't talk about a cyclic quadrilateral until you've proven it. Let's have a look. E2 is O1. Why? Because the line BC is a chord and it's subtended by line BC. E2 we have already proven 110, and O1 was given 110. Can you see that? Right, people? Let's just go up, up, up. There it is. E2 is equal to O1. Why? We've proven E2 110, and we were given that O1 is 110 on the sketch. Right. Then I say, they are subtended by line BC. We cannot call it a chord yet because we haven't proven this a cyclic quad. Be very careful with your proofs. Then you say, therefore, line BC is a chord. Therefore, EBCD is a cyclic chord. And the reason, chords are two equal angles subtended by the same chord. Two angles subtended by the same chord. There you are. There I've proven this cyclic chord. I wrote very small there, but I think this is reason enough. But if you want to make double sure, you write it again. There's two angles subtended by the same chord. That is why it is a cyclic chord. There I said it's subtended by a line. Then I said, but therefore, line BC will be a chord. You understand? Right, you use those three characteristics of a cyclic chord to prove a question like this. Thank you, people. Let's go on to the next sum. Geometry takes a lot of time. I hope you realize that. It's very important that you should realize that. Okay. Let's have a look at our next problem. In the figure, I don't like that, I like the word diagram. TRSW is a cyclic chord. They gave it to you, TRSW. Stop. Cyclic chord. Where's my cyclic chord? There it is. Let's see. What can I mark if I have a cyclic chord? I can mark opposite angles equal to 180. I cannot even actually mark it, but I know it's a cyclic chord. So when I do my problem, I must keep in mind that one plus that one will be 180 degrees. And that one plus this one will also be 180 degrees. Then, are there an exterior angle for this cyclic chord? There's one. And that T1 will be equal to the opposite interior angle. I marked it already. I marked it. They didn't mark it, okay? And then, are there diagonals? No. So we won't have angles on the same chord. But, look at this. They said TW is equal to WS. They won't say a thing like that unless they want you to use it. So, the angles on that chord will be exactly the angle on this chord. So those two, I marked it like that so that you can see it when you do your proof. Then they said, TW, okay, we worked with that. RT and RS are produced to meet tangent at VWZ. This is a tangent at the point where these two are lengthened to meet at V dot. But the tangent touches at W. Okay, tangent. What must we check if we have a tangent? We must check whether there's a radius perpendicular on the tangent. People, they did not say this is a diameter. You cannot just assume that it is a diameter unless they told you that there's a midpoint on this line, which is not there. That is why we don't have to check any of those midpoint theorems, because there is no midpoint. But now there's a tangent. There is no radius perpendicular on the tangent. There are only one tangent here and one there, so we don't have equal tangents. The third very important one, the angle between the tangent and the chord will be equal to, let me show you, to the angle in the opposite segment. So this angle will be equal to this one. Now if this angle is equal to this one, it will also be equal to this one, because we've said that these two are equal because of equal chords. People, can you see I'm only marking at the moment. I haven't looked at the questions. I don't want to look at the questions until I've marked everything that I've seen. There's another angle between the tangent and the chord going there. So this one will also be 30. I wrote it there, nobody else, I did. The only angles that they gave us is that one and that one. So this angle will also be 30. This one will be 30. That one will be 30. That one will be 30. Can you see that? A lot. Where must I start now?
Where you said this angle equal to 30.
30, 30, 30. Okay. Right, people, can you see that we've got a lot of angles equal to 30 by marking them? That one is that one is that one. These two are equal, so in other words, why are these two equal? Because they are on the same chord. So if we look at this sketch very quickly, we will see 4 angles that we have equal to 30 already. Right, let's go on. There's another tangent there. So, tangent. Are there a line perpendicular on the tangent? No, because that is not a diameter. Are there 2 tangents there meeting outside? No. Are there an angle between the tangent and the chord? Aha. R1 will be equal to W3. I've marked it like that. Let's mark it like that. Then, on this side, angle between the tangent and the chord, that 50 will be equal to this one. So this one is also going to be 50. I write it in another color. People, you don't see the colors on my sketch, but you do it in other colors. All this marking must be done in other colors. Because for each one of those, you'll have to give a reason. Why did you mark them equal? So please remember that you cannot just assume it's equal because you decided it's equal because you know the theorems. You must give a reason next to it when you use it. Okay. I want to show you another angle that can be equal. It's this one. This one will be equal to this angle. Why? It's also an angle between a tangent and this chord. It will be equal to the angle in the opposite segment. Can you see? So that whole angle will be equal to this angle. And you can do it on this side also. This whole angle will be equal to T2. But just don't mark too much things, just remember it. Go through all those things that you must check. Those things that I gave you at first before you look at any of these questions. Right. Now I think we can go to the questions. Give a reason why R3 is 30. Give a reason why R3 is 30. Now, people, we've marked it 30, but why did we mark it 30? They didn't say this line bisects the angle there. No, they only gave us that 30 and this 30. So now we'll have to think, why did we mark it 30? We said this is 30 because they are subtended by equal chords. Can you see? That angle will be equal to that angle. So now you must remember why you marked these things. So R3 is 30, equal chords subtend equal angles. That's your reason. Or you can say subtended by equal chord. Right. That is R3. Done. 9.3.2. State with reasons 2 other angles equal to 30. Now, that was given. We know now that this one is 30. Now, check this. We've marked these two 30 also. Why? Angle between the tangent and the chord will be equal to that angle. So, this one will also be 30. On this side, angle between the tangent and the chord will be equal to the angle in the opposite segment. So, T4 and W4 and W1 will both be 30 because of the tan chord theorem that we know. W1 is R3 there, and W1 therefore is 30 because R3 is 30. We've proven that. Then, and the reason there is tan chord. Then on this side, W4 is R2. We've already marked it, but it's also the tan chord theorem that we are using. And W4 is also 30 now because that one is 30. So now we've got 2 extra angles. They said state with reasons 2 other angles equal to 30. There they are. And you see, because we marked there, it's making it much easier for all of us. Okay. Then, number 9.3.3. Calculate the size of S2. There's S2. Oh, people, it cannot be easier. Ne? Look at this. We've marked this one equal to that one. Why? Tan, let me take my finger, tan, chord, up in the opposite segment. So W2 will be equal to 50. And that is because it is the tan chord theorem. People, I decided to do one or two that's not so difficult because geometry is a problem to, I think, most of you. Even if you are a candidate that gets 60, 70 or 80%, you lose a lot of marks in your geometry. So what I suggest, make sure that if there will always be a sum where you've got to determine angles, but then there will also be proofs. Make sure that these type of sums, you get full marks. The proofs might be difficult, and then you might have to leave it out. But you are going to try them, we are going to check them here, and make sure that you can do a proof. Okay, let's go on. The next question, determine V. There's V. There it is. Oh, people, now if you look at V, what corresponds with V? These angles, if I could get these two angles, I can use angles of a triangle. Or if I could get T2, T2 will be the exterior angle equal to the opposite interior angles. The exterior angle, T2, equals the opposite interior angles. We've got one there, and that's all angle that we have. So, but in the cyclic quad, we know that T2 plus S1 is 180. Look at S1. You see the stepping stones over the river. Go back to S1, because we can determine S1. In this triangle, we have two angles, because we've proven that one 30. That one we've proven 50. So we can determine S1. So let's start there and jump to that stone there and then jump to these two angles there. Okay, S1 is going to be 180, 9.3.3S. Okay, let's go to number, oh, it's V that we've got to calculate now. Okay, there it is. V, we got V equal to, what did we get the V? Oh, but we will still do the V. So let's quickly go up. S2. How are we going? Oh, I did it. You see, people, in geometry, you've got a lot of methods. This morning, I saw something else. When I did this at the beginning of the week, I saw something else, but both are 100% correct. They say S2 is the exterior angle of this triangle. Again, it's the exterior angle. Can you see how many times we've been using it in this sum? S2 will be that one plus that one. So S2 will be 80. Therefore, S2 will be equal to T2, exterior angle opposite interior angle. Have you got that? So that one will also be 80. This angle is the exterior angle of the triangle. That one plus that one. In other words, let's see. S2 is T2, so T2 is also 80. Then we say T2 is V plus W4, exterior angle of a triangle. I did not write my reason there. Exterior angle of triangle. That's my reason. Right, people? Therefore, V will be 80 minus 30. Can you see that? V will be 80 minus 30 because T2 is 80 and 80 is that one plus that one. and that is V plus 30. Therefore, V will be 80 minus 30. Can you see that? And that is 50. Well, just now I wanted to work in a different way. I wanted to determine this angle, S1, by using angles of a triangle. 80, so this one will be 100. From there, T2 will be 80. Why? Opposite angles of a cyclic one. And then we will be back at the 80 degrees, and it will give me 50. That's 30, this 80, so that is 50. You see, people, you can use your own method if you, and the people who sets the memorandum, if they get a sum like, if you did it in a different way, they will have to check whether you did it right, and then they will take your proof and put it with the memorandum. Because if your proof is right, they've got two proofs for that same sum, which is 100% correct. So you can use whatever you want to use in this case. Right, people? And then 9.3.4. 9.3.4. Just write the number in there. Okay, what would they say there? They said, prove that WR squared is RV times RS. Wow. We've done easy things up to now, and all of a sudden they say, prove that WR squared is RV times RS. Now, people, if they ask something like this, it's normally in connection with similar triangles. Because there's no parallel lines so that we can have ratios in triangles. So the only things that left, you must use similar triangles. But which two triangles are we going to prove similar? Look at what they've given us. WR is given twice. So it means WR belongs to both the triangles. Let's go to the sketch quickly. I just want to write down the question. WR squared is RV times RS. And then we go back there, and now we must decide on two triangles, which I want to prove similar. Now let's have a look. Why? Right. WR is twice there. So it means it's a common side to the two similar triangles. To prove similarity, we've got to prove 3 angles in the one triangle equal to 3 angles in the other triangle. Now let's have a look. If that is a common line, maybe we are going to use these two triangles. Now let's see. 30, 30, 50. What is this one? We don't have it. 80, 100. Can those two triangles be similar? Let's have a look again. 80, 80, 30. But then WR is not there twice. So let's have a look. Which triangle do you think we should choose there? Now I chose in the end, I chose WRS, WRS, and WRV. Can you see? You use this. It's easier sometimes to go back to the question and see whether you can use the symbols in that question. WRV, WRS. Let's see. WRV and WRS. You see? We looked at those two. But in the meantime, the WR is also a common side to this large triangle and this triangle here. Can you see? So if you can't see it on the sketch or you're not very sure, you go to what they asked you to prove and see whether you can get triangles out there. But now, people, a very important thing when you prove, I want you to make sure that the correct numbers or letters there corresponds to the correct letters there. Let's see. W is equal to, the W is in this sketch is 50. In this sketch. The W in this sketch is what? No, it's not 50. So our order here is not correct. Be careful now. When you do your proof, you make sure that you work from the big triangle to the smaller one or other way around, and you make sure which angles correspond. And then you rewrite these in the correct order. It's always easy to first do your proof. We're going to say W2. Oh, I worked from the small triangle to the bigger one. W2 is equal to V. It has already been proven 50 degrees. Then, so I worked from VRS, from this one. W2 is equal to V. There's the other one. Then R2, oh, you see, I swapped these around and I shouldn't. I started here. So I'm going to rewrite that one. R3 is equal to R2. R3 is equal to R2, and we can only say proven because it has been proven already. Right. Then I'm going to look at the next angle. W3 plus 4. Again, this is the big triangle. So I'm going to swap those two also. I'll show you now why. I was too lazy to swap them because I saw the two triangles without proving it. Right, people? So that is equal to that. Therefore, these triangles will be similar. People, if you've proven two angles equal, the third angle will be automatically equal. You don't have to give a reason for this one. Can you see that? Okay, now, the order now, I'm going to write that one there also. Now you can get the order from here. Because here's the small triangle and there's your big triangle. Can you see that? Therefore, triangle WRS will be similar to VRW. Have you got it? So if you work from the same triangle to the other, every time you prove an angle, the order here will be the correct order for those triangles. It's very important that you do have the correct order. And what's your reason for this, people? You must have a reason. The reason is going to be angle, angle, angle. That's your reason for this similarity, right? Now, people, in all the sums where you work with similarity, the first thing you do, you write your ratios before you look at the question that they've asked. What do I mean by the ratios? First two divided will be equal to the last two divided, and they will also be equal to 1 and 3, 1 and 3, WS and VW. But then I go to my question. I want WR squared. WR. People, whether you say WR or RW, it's exactly the same thing. If you take these two ratios, these two, you've got everything you need. If you cross multiply there, you will get WR squared. If you cross multiply there, VR times RS. Straightforward from there. This is not a level 4 sum. I don't think so. I should think this is level 3. This one. The others, level 1 or 2. So please, 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 make sure you can do a sum like this. And remember, when you've proven similarity, you write down the ratios immediately. And then you go to the question and say to yourself, wow, this is what I need. So these two ratios, I'm going to use them for my proof. People, I hope you understood that one. Let's go on to the next one. I wrote there, and I'm going to remind you all the time, know your theorems. People, the theorems from grade 11 is 1, 2, 5, and 9, plus grade 12 theorems. Those are the theorems that you should know. They will ask you 2 of them, and that gives you at least 10 to 12 marks in your pocket immediately. Question 7. In the diagram AB, close that one first so you don't see the answer immediately. Okay, in the diagram, AB is a chord of the circle with center O. M is the midpoint of AB. So what do you know about this angle here? It will be 90 degrees. It's your first theorem from grade 11. A line from the center of the circle to the center of a chord will bisect the chord and it will be 90 degrees on the chord. Okay, I actually repeated myself there, but you know the theorem. Okay, M is the midpoint of AB. MO is produced to P, where P is a point on the circle. OM is equal to X. There, they gave it to us. AB is 20. AB is 20. So what do you know about each one of these? 10, 10. But you'll have to prove it because you wrote it in there yourselves, okay? And PM over QOM. PM, okay, over OM is 5 over 2. I'm going to, okay, but it is there on top. I can see it when I do the first sum. Right, let's have a look. That's what was given. 7.1. Well, write down the length of AB. Now that is stupid common level 1 question. AB is going to be equal to AM is MB, and they wanted us to find MB. Yeah. So MB is 10 units. 1 mark only, but it's so easy. And 7.2, the question there, they said, give a reason why OM is perpendicular on AB. Why OM is perpendicular on AB. Give a reason for that. That is your theorem 1, grade 11, and the reason that we are going to use here, the line from the center to the midpoint of a chord is perpendicular on the chord. Have you got that? Wonderful. Level 1, because it's things that you should know from your theorems, people. Then, 7.3. Show that OP is 3x over 2. Now, people, you had a midpoint there, or you have a midpoint there. And that means OB will be equal to OP because they are both radii. Keep that in mind for this one because they said, show that OP is 3x over 2. Okay, we are going to start with the ratios because this is going to be part of ratio question. The ratio that they gave us, PM over OM, is 5 over 2. They gave us that. Now we go on. We need to get to OP. Now OP is a radius and OB is a radius. Now let's see whether we can get, by using that, something that we can use to find that answer, which is not going to be so easy. Okay, we know now that PM over OM, 5 over 2. But we can also say PM over OM is 5 over, or we can say OP plus X over X. This is where it is a difficult problem. Look at this. PM over OM. PM will be OP plus X. OM is X. So that same ratio can be written like that. This ratio. OP plus X is PM. X is OM. We need those X's. Can you see that? So I went to the X and brought it into that ratio. Because in the given ratio, there's no X given. Right. Then we said, OP plus X will be 5 over 2 times X. I cross-multiplied. I took this whole fraction and I multiplied it by X, and I put it on a 1, and I multiplied that by 1. Can you see that? You could have done it in a different way. You could have said OP plus x over x is 5 over 2. Therefore, 5 OP plus x is equal to 5x. That is plain common cross multiplication. But we want OP. So we're going to say, divide that 5. No, it's 2. This one is 2. Am I stupid? 2 times that one. Then you say, right, divide the 2 into the 5 there. Then we'll have OP plus x is 5 over 2x. And then we are exactly where we are there. But it takes more time. And you are allowed, people, to do what I did now. You say 5 over 2 you keep. And then you say x times 5 over 2. OP plus x times 1. You put that fraction on 1. And that will give you OP plus x. But you are welcome to do it like this also. You will get to exactly the same answer. Okay, people? Now we can say OP is 5x over 2 minus x. You see, now I've written OP in terms of x. But it's not in its simplest form. Let's have a look. It's fractions that you can add because its x is there. The common denominator is 2. So you divide that common denominator into that one. It's 1 times 5x. This one is over 1. 1 goes into 2 twice. 2 times x. Exactly like you did fractions in grade 4. Because I know this because my grandchild is in grade 6 now. And she's been doing fractions since, the one in grade 3 is actually doing fractions already. So people, you came with fractions for 7 years now. So you should be able to know fractions. And I know some of you will still say to me, miss, if I see a fraction, I want to faint. Don't be like that. A fraction is really not difficult. You use the same rules. You must just be careful because there's a fraction involved now. Okay. Right, people, let's go on. So OP is 5x minus 2x over 2. We want to get there. 5x minus 2x is what? It is 3x over 2. Did we get to that answer? Yes, people. Wonderful, wonderful, wonderful. Now, 7.4. Calculate the value of x. How do we calculate a variable? We must have an equation. Otherwise, you cannot solve for x. Because if they say calculate the value of x, they are actually saying to you, solve for x. Now let's get to 7.4. OB is OP. I use that knowledge now. Why? Because I want to get into this little triangle. Do you really think you were not going to use this knowledge, the 90-degree knowledge? Where's my sketch? This. They gave it on purpose. And they asked us, why is that 90 degrees? They asked it. Now, people, if they asked it previously, you normally use previous proofs for every next proof, most of the times. So they've asked all the questions to lead you to 7.4. Right. In this little blue triangle, look at that one. What do we know now about OB? It's going to be OP, and that is 3x over 2. It's very good to go back to your sketch and write in the things that you have calculated already, if possible. But they will give you larger sketches on your sketch page, or you will get a book in which you will do your paper, and the sketches will be larger so that you can work on the sketch in your book. If they give you a separate sketch page, all the sketches in the paper will be bigger on the sketch page. Then you work on the sketch page, and you make sure you hand in that sketch page also, because they will have to take your sketch page and watch how you came to your answers from your sketch page. Sometimes you have to number an angle. And if you use that in your question paper and they don't have your sketch page, they will not know whether it's the right angle that you use there. So please, that sketch page is important. If you get a book, it's a bargain, because then you can do everything there in the book and you can do the sketch right on top where you are doing your calculations. Okay? Right, people? Now, can you see there? I haven't used that 90 degrees, and there they asked it in 7.2. Why is those two perpendicular on one another? Right. So, what can I do in this triangle? Oh, knowledge from grade 7, Pythagoras. Pythagoras. The hypotenuse square is equal to the two other sides squared, the sum of the squares of the other two sides. That is Pythagoras. So now we're going to triangle OMB. I first said OP is OB, and it will be the same now because they are radii. Then I said, let's use Pythagoras. OB square is OM square plus MB square. Don't be afraid to write your formula down first, people. It makes it easier because you can easily get confused with these things. And don't be the reason for your confusion, please. OB is 3x over 2. OMX is x squared, and MB is 10 squared. But Pythagoras, I square that side, 9x over 4, x squared plus 100. Okay, now I want to determine x. So I'm going to try to get my x on the left-hand side now. There you are. That's x squared, that's 100. That is 9 over 4. Right, now I want x on the same side. So I'm going to go there. I take my 4 to the left-hand side. It becomes a negative. 5x squared is 400. Get rid of the 5. You can never solve an x with an exponent unless it's all alone on the one side. I've said that more than once to you, okay? So get rid of the 5. That will give you x squared is 80. Therefore, x is going to be the square root of 80, and that is 8,944. This was these two questions were the only level 3 questions, maybe level 5. Level 4, I don't know. Not so difficult. The first two was easy, but people, let's just go back there. Can you see? The first question was only 1 mark. Easy. A reason, 1 mark. Easy. And then the 5 marks left were a little bit more difficult. Quite a little bit more difficult. Okay. So it's always in geometry, most of the times. The first questions are easy, but it's not a lot of marks. Then the last question maybe will be the level 4 or 3 question, which will be more marks. That's why it's so important that you people really try to do all the questions in your geometry. If there's 1 or 2, 3, and 4 mark questions that you can't do, people, don't worry about that. Just make sure that you do those that you can do as well as possible. Okay, let's go on to another question. Right, this is question A. This comes from an IEP paper, or where there's A's and B's, it is the IEP. They number their questions like that. They say question 5A. We say 5.1. Okay, let's have a look. In the circle below, draw any 2 chords. They only gave us a circle. That's all they gave. I did this one because I really want you to quickly see that you can do something like that also. They said, in this circle, draw any 2 chords, not diameters, AB and CD, intersecting at E. So there's 1 chord, AB and DC. They must intersect. So you can't draw a little chord there and a little chord here. they must intersect one another. That's what I did there. And then they asked a very simple question. The problem is some of you won't even know how to draw a chord. No. I'm sure you will know how to draw a chord. There will be people that won't know. Okay. Prove that AEC is similar to DEB. That is really very simple. Because people, you know that if there's a chord there, or in this, you can actually draw a little chord in there, but normally you don't draw it, you just work with this segment, okay? The angles on the same segment. That one is equal to that one. Those two are vertical opposite. And from that segment, AD, you've got C and you've got B. Can you see it? So that theorem, I told you, you must really check for that one when you check your things in the circle geometry, okay? So all those angles are equal, therefore the two triangles will be similar. Let's make sure whether the order is right. A and D, they are equal. E and E, they are equal. C and B. So this order, most of the times if they give it to you like this, the order will be correct. But just check it to be sure about that. Okay. Right, people, now how do I prove that? In triangle AEC and triangle DEB, A is D, angles on the same chord or in the same segment. The chord is actually not drawn there, but if you draw it, they won't take your marks. B is C, angles on the same chord. E1 is E2, vertical opposite. And then those two triangles will be similar, angle, angle, angle. All these reasons are very, 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 very important. This is a straightforward question now. The drawing of the chords was actually maybe a level 2. Then, the next question. What did I say? The moment you've proven two triangles similar, the next thing you do, you write your ratios. From B, I wrote my ratios. AE, DE, EC, EB, AC, DB. Then I'm going to look at the question. The question said AE, EB, AE, EB, CE, ED. Ha. So it's these two that we're going to use. You can't use all three of them. Sorry. Let's quickly have a look again. You draw, you write down the ratios from that similarity. Those two, then 1 and 3, 1 and 3. They will all be equal ratios. And then I'm going back to my question, and I see all 4 of those sides are in these two ratios. So those are the two ratios that I'm going to use. People, this is a very easy one because it's straightforward, like the previous one also. Sometimes it's not so easy because sometimes one of these sides are equal to a side in another triangle. You must substitute it there, and before you will get to your final answer. But you check that, you check your ratios, then you check what you have, and then you substitute wherever you should substitute. Okay. Then I do cross multiplication. AE times EB is equal to DE times EC. Now people, if it's different way around, then that doesn't matter, people, you've proven. And I, just to make sure, I said, let's swap it so that it looks like that. CE and ED is the same as those two. Can you see that? So I swapped it so that I could answer my question 100% correctly. It's important, people. It's important that you always get to the correct answer. What they ask, you must, in the end, get to. Okay? Thank you. Another one. Oh, now we are going to do a little bit more grade 12 work. Okay, let's have a look. 9.2. In the diagram ABCD is a parallelogram. Stop. What do you know about a parallelogram? The sides are parallel, the opposite sides, but those sides will also be equal. Do you agree? They will also be equal. Right. Then the opposite angles will be equal, but you're not going to use angles here because it's parallel lines that we are working with. And those two angles will also be equal. Just go through the parallelogram's characteristics or properties before you jump into the sum, because they won't give the parallelogram unless you are going to use it. There's another property. The diagonals bisect one another. Now, these little things I wrote in while I was doing the sum. But you can actually mark them. That one is going to be equal to that one. It's going to be of great help to you. Okay. Now, let's go to the questions. Parallel, we've got alternate angles, but we are not really worried about angles. And then they said, parallelogram, M and F is a point. I said AF to DFD is 4 to 3. Aha! AF to FD. I wrote it in there. If you write it on your sketch, it's much easier to see what you're doing on your sketch. Okay. Right, people. Then we're going to the questions. Calculate. Oh, EF. Oh, and there's also two lines that's parallel to one another. I'm going to put it in there also. People, before I go to the questions, I want you to look at which triangles can be used so that we can work with the ratios. A triangle must have, one of the sides must be parallel to a side inside the triangle. So there's one triangle that we will have to work with. Okay? But can you see there's another triangle here that we might work in also? Can you see that? It's this one, because one side of the triangle is parallel to a side inside. It's this one. That side is parallel to a side inside the triangle. Mark the possible triangles that you can work in. It's very, very important. Right, people, let's go to the questions. Calculate, giving reasons, the ratio of EM over AM. Now let's have a look. EM over AM. Can you see we marked that triangle? And in that triangle, we can say that FD over DA will be EM over MA. Can you see that? EM over AM. Same thing. Can you see? If you start on this side of the triangle, you start on that side of the other side also. If you start there at the vertex, you must start there for both. You will say AF over FD is AE over EM. But in this case, they worked with the long side and the short side. The long side and the short side. Now, in that triangle, those ratios will be similar. Now, people, I love it if you write your question like this. You start with, in triangle AMD, EF parallel to MD. Because you saw that, you marked it, and that is actually your reason why you're going to say the ratios now will be the same. So you don't have to give a reason again. You choose your triangle, you write the two parallel lines, and then from there you conclude. AF to FD. AF to FD is 4 to 3. That was given to us. But now they ask us to determine EM over AM. That means FD over AD. Now FD over AD, or ratio of that, is 3, and the total there is 7. Have you got that? Very, very easy, that one. So therefore, it's going to be the same as EM over AM. There I wrote as a ratio so that you can see that a ratio and a fraction is exactly the same thing. So EM over AM will be 3 over 7. Okay, done. I'm going to write it in there, and there it is, 3, 4. I wrote it in there. Can you see that? Because that's going to help me with the next part of the sum. 9.2.2. Give reasons and calculate the ratio of CM over ME. CM over ME. We don't have these ratios. So we will have to work with something else in this little triangle. And look at this. If the ratio there is 4 and 3, this line will be 7. And then this line will also be 7. Why? It's a parallelogram and the diagonals bisect one another. So the ratio of CM over EM, 7 over 3. How easy can it be? Okay, but remember that parallelogram, the diagonals, because if you didn't know that, you wouldn't be able to do 9.2.2. You must know all the properties of all your quadrilaterals. It's important because they are throwing it in everywhere. Okay. Then 9.2.3. Let's have a look at it. I don't want to take the sketch off. I want you to see the sketch. There they said, calculate, giving reasons, the ratio of. So we want to calculate the ratio of that. Now let's have a look. FDC is here. Here, where's my red pen? But you will not see the red. That one. And BDC is going to be this whole triangle. Yeah. See it? So it is this triangle, only this one, and that one there. They say you now must compare the ratios of the two triangles' areas. Now let's have a look. How do you determine area? Half base times height in normal geometry or measurement. Half base times height. Now let's have a look. What will the area of FCD be? That's the base, and the height will be the height of the parallelogram. Why? Because they are between the same parallels. If I should draw in a height for this triangle, I can draw it here, I can draw it there. It will be the height between the two parallel lines. My hand is always in your way because this is my stupid hand and this is my bright hand. You see that? But this bright hand is in the way all the time. So let's use my stupid hand. Okay, there's your triangle. Half base times height. And the height is the distance between the two parallel lines. So I'm going to write it there. I'm going to say the area of triangle FDC is a half of FD times the height. Then the area of DBC, this one, half base times the same height. Can you see that? Because these two triangles are both between the same parallel lines. And the distance between parallel lines are constant wherever you go. Okay, so let's write the area of BDC. It's going to be a half BC times H. There it is. The H's are the same. Why did I use this? I gave a reason for that. Triangle FDC and triangle BDC is between the same parallel lines. Therefore, their H's are exactly the same. I can cancel that one. I can cancel that one. Right. So now I have the area of that over the area of that is equal to FD over BC. My FD over BC is 3 over 7. Let's see whether I am right. FD over BC. If that is 4 and 3, that one is 7, then this one will also be 7. I wrote it in there. They didn't give that. But you see, I'm working with that one that they gave us all the time. So that one is 7, and FD is 3. So what's the ratio? 3 over 7. BC is equal to AD, and that's why it is 7. It's all ratios, people. There are no distances here. That we are working with ratios. And that is the opposite. Why are they equal? Opposite sides of a parallelogram. So you see how we used the parallelogram? We used it throughout the sum. So be careful when you get a sum like this. Mark everything you can mark and see whether that won't help you to get to your final solution. Nice question, because they don't always ask to compare areas ratios. So this, I thought, is quite a nice question. If you get something like that now, you will be ready for that. Next one. In the diagram below, O is the center of the circle. Now let's have a look at our diagram. O is the center of the circle, and it's two concentric circles. What does that mean? They've got the same midpoint. But the one has got a small radius, and the other one has got a large radius. Okay? That's concentric circles. You can draw more in here. Okay? AE is the diameter of the largest circle and is 20 units. I'm going to write it here because if you mark it on your sketch, it's quite difficult to see this. 20. That means AO will be equal to OE. They are radii. Therefore, OA is OE, and that's going to be 10. We are going to use this somewhere in our sums. Then they say GF is the diameter of the smallest circle, and it's 8 units. So what will OG and OF be? They will be equal because they are radii, and that is going to be equal to 4 each. Okay, next. Chord AB has a length of 12. I wrote it in there. It wasn't there, I wrote it in. People, take your time reading your questions. Same with all your mathematics, but especially geometry, analytical, and financial. Because if you don't understand what they gave you, how will you understand the questions? Then what they gave you, you try to write it right next to your sketch or show it on your sketch. But it's difficult to show this. I can actually say that is 4, that is 6, because both of them are 10. This one is 4, and that one is 6. Can you see that? Oh, I'm writing very small because I don't want to mess up the sketch before we start with our sum. Right, and then they say, OD is perpendicular to BE. Wow. If a line from the center goes to a chord perpendicular on the chord, it will bisect the chord. So those two will be equal, but did they give us? Yeah, they gave us the length of BE. No, AB. They only gave us AB. They said OD is perpendicular, but they did not give us those lengths. OC is parallel to GB. There they are. OC. Okay, let's mark the triangle where we've got the two parallel lines. It's going to be this triangle. People, you see, I haven't even looked at the questions. I've been applying my knowledge in the sketch so that I make it easier for myself, people. So there's your triangles and there's the two parallel lines. So your ratio will be like that. BC over CE is GO over OE. Or BC over BE is GO over GE. You've got 3 types of ratios there. Always start on the same side of the triangle when you do your ratios. I'm repeating that because you do forget that. Okay. Right. Now we can go to our questions. Determine, giving reasons, the length of BE. Now, where is BE? There it is. There it is. Now, these are lengths because they gave it to us as lengths. So, people, 4, 4, 6. 4 over 10 will be 4 over 10. Have you got that? But they want the length of BE. Oh, very, very, very easy. 4 over 14 is 4 over 14. 4 over 14 can be simplified. It will be 2 over 5. So the ratio of both these are actually 2 over 5. But the real length, 4 over 10, then this one is 4 over 10. But that can actually be more. It can be something else. The length, as long as the length brings us back to the ratio 2 over 5. Okay. Now let's have a look. Giving reasons BE. If I say this is 14, then that one will also be 14. And B, oh, that's all they wanted, the length of BE. So you're going to say 14. BE, the ratio, no, I'm going to work with the ratios first. That is the midpoint of, I wrote everything down there, okay? Then number 1, I want BE. Now BE, there it is. Now if I say BE squared is AE squared, minus A. Do you see what I did? I wanted to take another method now because there's another method also. But what I did when I did this sum, I used Pythagoras. Because people, there's a diameter. This angle will be 90. Can you see that? Forgot to mark that. Now you can see in this large triangle, I've got this side, I've got that side. So I can determine BE by using Pythagoras. BE squared will be hypotenuse minus that one squared. Okay, so it is 20 squared minus 12 squared, which will give me 256, and BE will be 16 units. 16 units. Have you got that? Wonderful. You cannot say, you can say the ratio here is 8 and 6, 14 towards 4. In other words, 2 over 5 or 5 over 2, ne? But that's only the ratio. And you don't have any of those lengths. So your only solution will be to use Pythagoras there. Okay. The other method that I thought of, I don't think it's going to be easier. This one is the easiest method that you can use. Yeah. Okay. Right, people. Question 2. Determine giving reasons BC over CE. BC over CE. Ah, people. Can you see it's 4 and that one will be 10. Ratio, not length. Ratio. 4 over 10 or 2 over 5. Let's have a look. GO is OF. I wrote it there because nobody gave it to you. You realized it because this is the midpoint of the circle, and those two are radii. With the large circle, the same thing. 2 radii. So I wrote it down because they are radii. I want to write there radius. AO is equal to OE. Also 20 divided by 2, and it's also radii. Right, then, oh, I wrote it there. I thought, why didn't I write the reason? But there it is. So C and CO is parallel to BG. You see, I'm writing those things down before I do my proof, because that is actually part of my reason that I'm writing down there. Okay, and then I'm going to say it is 4 over 10. because GO over E is 4 over 10, or you can say 2 over 5. So BC over CE will be 2 over 5 or 4 over 10. But normally, if it's a ratio, you simplify it. And then the ratio there is 2 over 5. Let's go there so that I can show you that. BC over CE is 2 over 5. And therefore, BC, it's because of the fact that GO over OE is also 2 over 5 or 4 over 14. But rather use this one where you've simplified the ratio, because you should simplify a ratio. Okay, then the last one. Hence or otherwise, determine, giving reasons, the length of CD. Now this is the difficult part of this sum. There's CD. Can you see it? Do you have this length? No. Do you have that one? No. Now, how on earth are we going to determine the length of CD? CD is only part of CE. There's no parallel line corresponding those. So, some other method must be used now to find CD. Now, let's have a look what we are going to do. We're going to say OD is perpendicular on BE. They gave it to us. Therefore, BD is DE. BD is DE. Why? Line from the center perpendicular on the chord will bisect the chord. I've marked it already. Line from center bisects the chord. I just want to get the sketch back to us here. Okay? So BE is 16 units. We've proven that. There it is. There it is. We've proven BE already by using Pythagoras. Can you remember that? In other words, BD is DE, and that is 8 units because of this reason that we have here. I'll go back to the sketch whenever we need it. Then we'll say BC over CE is 2 over 5. We already proved that. Therefore, BC over BE, BC over BE, we've already done that also, is 2 over 7. BC over BE. Can you see that? Is 2 over 7. Therefore, I want BC. I'm going to say BE times 2 over 7 is equal to BC. BE, cross multiply, but take the whole fraction. Put this one on 1, is BC times 1. Is BE times 2 over 7. Why did I do it? Because I want BC. I want BC. So let's have a look. So BC is 2 over 7 times the 16 that I got for BE. I can get an answer there. It is estimated to 4,57. There it is. And then that is BC. But we know that these two are equal. BC is 4,57. Now we can say that CD is BD minus BC. Difficult, very difficult. And BD is 8 because they said this is 6. We actually proved this as 16. So CD will be BD minus BC, 8 minus 4,7, 3,43. Voila! Not so easy, ne? Not so easy. So what did we actually work with? We worked with the length of BE that we got there already. We worked with the ratios. BC over CE is 2 over 5. But then we said BC over BE is 2 over 7. BC over B over CE is 2 over 5, but BC over BE is 2 over 7. Now we want actually BD, ne? Okay, now we're going to go directly, we've got BD, directly to BC over BE, 2 over 7. We want BC, so that we can subtract it from that 8 to get CD. So we're going to work with that half of the line BE, or the chord BE. So BC over BE is 2 over 7. Then I cross multiply, and I put my BC on the one side. I do have BE. It is 16. So now it's 2 over 7 times 16, and I got 4,57. And then to find CD, I must take BC, and I must subtract it from the 8 that I got there, when they gave us the length of BE. This is your difficult question, people. And I really suggest that you look at it again, and maybe again. And make sure you understand where I got everything from. I hope you understood it. The problem is, in these sums, you don't know where to start. You don't know where to start. But people, we haven't been using that perpendicular line there. And they will not give it to us unless we have to use it. So now you say to yourself, how can I use it? And then I use it for ratios here, because that D is bisecting that line. And that's why the ratio 2 over 5 becomes 2 over 7 if I take the whole of that line. But I do know that this is 16, 8, 8. So I used it. Very, very important. I used that 12 with Pythagoras. If I didn't use that, there's something wrong, because I must use everything that they gave me. So if you struggle with your last question, you say to yourself, what is it that I haven't used yet? Maybe that will help me to get to my final answer. Thank you, people. That was our last sum for geometry. You get much more difficult sums. Maybe we can do a few more difficult ones for the September and the final exam. But I think for the June exam, this is the best. You won't get very, very difficult ones in the June exam. But I think we must take up 2 or 3 sums later, so that we do much more difficult ones for the final exam. Thank you, people. Good luck with the geometry, which is a problematic topic. People, I want to do another sum for geometry before we leave the geometry. I've almost forgot about this sum, but I do want to do it with you. There's a lot of things in here that is of a lot of importance. Okay, let's have a look at this sum. It's B. In the diagram below, circles with centers P and O are drawn. Right, centers P and O. So in both these circles, we have a midpoint. Right, let's go and have a look. Mark everything you know about a midpoint in your circles. Let's go to the little circle. There's a midpoint. There is no line from the midpoint on a chord that bisects the chord out. There is no diameter, that should be like that, with an angle of 90 degrees. There are 2 radii. There they are, the 2 radii. I've marked it already. Okay, but there's no line there, so I doubt whether we're going to use that. Then there's an angle at the midpoint going to BC, and that is going to be twice the angle on the arc. So P is going to be 2A. Have you got that one? Right. And what else did we? Oh, we must always look for 2 angles on the same chord or on the same arc. There are only 1 angle there. So that's all we can mark in that small circle. Let's go to the other circle. There's also a midpoint. What do we know about a midpoint? We must check for radii. There they are. But again, people, there's no chord there. So we are not going to use an isosceles triangle. There's a angle at the midpoint, which will be twice the angle on the arc. But there's no angle there on the arc from here to there. So there's another angle at the midpoint. That's why I'm doing this, some people. Because here they are using a lot of different things that you are used to. This angle, this reflex angle, will be twice K2. Can you see that? Because it's the angle at the center, the reflex angle at the center will be twice the angle in the opposite segment. You've got that one? Right. So remember those two. This one is twice that one. I've marked it like that, okay? Then I marked the radii already. There's no diameter. There's no line from the center perpendicular on a chord. So midpoint is done. Then we go to cyclic quad. Are there a cyclic quad? They didn't mention anything, but look at this. DKEO. Is that a cyclic quad? No, people, no. Some of you would have said that. It is not a cyclic quad. Why? Because O is not on the arc of the circle. So this is not a cyclic quad. Thank you for that. Okay, then, cyclic, so there is no cyclic quad, so we can't use any of those properties. Are there tangents? There are two tangents from the same point on the bigger circle. So those two tangents will be equal. I've already marked it, okay? That means if there were a chord, these two angles would have been equal because those two tangents actually makes an isosceles triangle. Right, so there is no such thing that we're going to use that. Right, what else do we have in this circle? Oh, tangents. We've just marked the two equal ones, but we haven't marked radius perpendicular on tangent. There it is. I've marked it. Radius perpendicular on tangent. And then the last theorem for tangents, are there any lines or angles between a tangent and a chord? There's the chord. This is not a chord because it's not in a circle. It's that little angle. It should be equal to an angle on the arc, but there's nothing that one will be equal to. Can you see that? Same on this side. That one should be equal to an angle here on the arc, but there's no angle on the arc. So we are not going to be bothered much with that one. Okay, so now I think we've marked most of our things. Remember all your old knowledge also? And then let's go to the questions. Prove that O1 plus 2A is 180. Immediately, this is not level 1, but really not level 4. Rather level 2. I would say that. There I also wrote again. Remember to mark everything you see with your color pencils. People, can you see how I've been marking in all these questions? I've been looking for a midpoint. I look for everything around the midpoint that I can mark. Go to the cyclic quad, go to the tangents. Please learn that from your heads. That first page that I did with you. What do you check when you see a midpoint? What do you check when you see a cyclic quad? What do you check when you see a tangent? Okay. Right, let's have a look. Prove that O1, there's O1, is equal to plus 2A. O1 plus 2A there is equal to 180. My goodness. How on earth are we going to prove that? Now let's have a look. O1 is the angle at the center, but it doesn't have an angle on the arc. That is what we have to prove. You see, I write it down because then I have it in my calculation. I can just look up. I don't have to go back to the sketch and the information every single time. Prove that O1 plus 2A is 180. This is the question. So, let's go. The first thing we do here, we say, right, I've got to prove this DPEO a cyclic quad. People, this is the only solution. Because you know what? If you look at this sketch, how on earth are you going to get that plus that to be 180? It will only be possible if this is a cyclic quad. And look, it's very easy to prove it's a cyclic quad. Because there we've got 90, there we've got 90. The opposite angles there is adding up to 180. So this should be a cyclic quad. Therefore, that one plus that one should be 180 also. But that one is not 2A or 2A. Yes, it is. We are going to say that one is 2A because that is the angle at the center twice the angle on the arc. But that means we've got a lot of steps to follow before we will be able to get to the final answer. So where do we start? We're going to say E1 plus 2 is 90, radius perpendicular on tangent. Then we're going to say D1 plus 2 is 90, radius, you shouldn't do that, well, let me write it out. Radius, I was very tired at this time, perpendicular on the tangent. Okay. And if those two are adding up to 180, it means this is a cyclic quad because the opposite angles adds up. You don't say it is already a cyclic quad. You prove it by using those 90 degrees. So now you're going to say D1 plus 2 plus E1 plus 2 is 180, but they are opposite angles. I didn't say of a cyclic quad. Therefore, DPEO is a cyclic quad because the opposite angles adds up to 180. In other quadrilaterals, that is not necessary, will not necessarily happen. But the moment they add up to 180, we can say that that quadrilateral is a cyclic quad. And the reason is, we have proven above there that those two angles adds up to 180. And the moment they add up to 180, it will be a cyclic. So now we can say DPEO is a cyclic quad. And now we can use all the properties of a cyclic quad possible to go to our other proofs. Right, let's have a look. If DPEO is a cyclic quad, it means O1 plus P will be 180. Then we say, but P is 2A. We've got to give you a reason for that. We've marked it, but we just can't assume that it's true now before we give a reason. So we're going to say P is 2A, angle at center is twice the angle on the arc. You have it there? Okay. O1 plus P is 180 because we've got a cyclic quad there, but P is twice A. Why? Because it's the angle at the midpoint or at the center equal to twice the angle on the arc. You must give your reasons and you must take it step by step. I told you yesterday, rather write too much than too little, especially also in your geometry. It's very important that you write every single step that you can't look at this and say, oh, I marked that equal, so I can just say it will be equal. And I don't do all these steps in between. No marks. No marks. They want to see your stepping stones with which you're getting to the final answer. So show it to them. Okay. Right, people, let's go on to question 2. Prove that C3 plus E1, C3 plus E1 is equal, no, E1 plus 2 is equal to, that's the question. No, they didn't, I didn't write the question. The question is equal to 90 plus A. Prove C3 equals to plus E1 equal to 90 degrees plus A. So somehow we've got to use that A, and the only place that we used it was there, when we proved that 01 plus 2A is 180. So we must use that knowledge. We want to come back to 2A or to A again. E1 plus C3 should be 90 plus A. Now let's have a look. I don't have E1. I don't have C3. Go up to the third angle in that triangle. I don't have it, but I've got that one. And what does that mean to you? Exterior angle equal to the opposite interior angles. So if I can get K2 in terms of A, then I will be able to say that that is also going to be the sum of those two. Exterior angle of triangle. Now let's have a look whether we will be able to get to K2. Let's go on. We said 01 plus 2A is 180. So 01 is 180 degrees minus 2A. There's 01. Then we'll say 01 plus 02 is 360. It's a revolution. Then we're going to say 02 will be 360 minus 01. But 01 is 180 minus 2A. Oh, people, it's a lot of reasoning, eh? You must be careful when you do this. Okay, let's go on. You see, we're using this because we need A in our answer. Let's go on. 01 is 180 plus minus 2A. But people, let's go on. So 02 is 360 minus 01, which is this. I write it in there. So 02 is 180 plus 2A. And what did we say right at the beginning? This is the reflex angle at the center of the circle, and it's going to be twice K2. Can you see that? 02 is twice K2. Angle at the center is twice the angle on the arc. There you have it. So, but 02 is 180 degrees plus 2A. Therefore, 2K2 will also be 180 plus 2A. So, K2 will be the half of that, 90 plus A. And K2 is the exterior angle equal to C3 plus E1. Look at that. There was the question. See, K2, let's go to the sketch, is the exterior angle of this triangle here, and it will be equal to C3 plus E1. We've got K2 now. K2 is 90 plus A. Therefore, C3 plus E1 will be 90 plus A, because there I said, but K2 is C3 plus E1, exterior angle of a triangle is my reason for that. And therefore, C2 plus E1 will be 90 plus 8. People, I can explain it over and over again, but I think you must just listen to it over and over again. Otherwise, I'm not going to finish paper 2 today. Thank you. Now I'm done with the geometry. Let's go on to analytical.